When assumptions collapse, how drone swarms are dismantling modern air defense. In the early hours of the morning, under conditions designed to favor the defender, two separate but strategically linked operations exposed a critical vulnerability in one of the world's most heavily layered air defense architectures. What unfolded was not a failure of equipment, training, or firepower, but a failure of assumptions. Across a Russian coastal defense sector and deep inside a strategic missile testing facility at Kapustin Yar, lightweight unmanned aerial vehicles achieved what cruise missiles, electronic attacks, and saturation bombardment could not: the systematic dismantling of situational awareness, command coherence, and strategic deterrence. The outcome was not dramatic destruction visible from space, but something far more consequential: blindness. Phase 1. The Coastal Defense Breach. A quiet beginning. At 03:18 a.m., radar operators detected 8 low-altitude contacts approximately 20 kilometers offshore, flying below 50 meters at speeds between 100 and 110 kilometers per hour. These were traditionally associated with non-threatening aerial clutter, birds, debris, or malfunctioning civilian drones. Electronic warfare systems were activated immediately. High-powered jammers saturated the airspace with interference designed to sever satellite links and disrupt commercial-grade control systems. According to doctrine, the targets should have failed within seconds. They did not. The objects maintained disciplined formation, spaced roughly 80 meters apart, adjusting altitude in precise increments. No signal degradation occurred, no loss of control. Thermal sensors detected almost nothing, electric motors emitted minimal heat, and radar returns were indistinguishable from seabirds. Within 1 minute, a foundational assumption collapsed. These drones were not dependent on vulnerable control links, predictable flight paths, or thermal signatures.
Missiles and guns fail. At 03:20 a.m., a Panzer S-1 point defense system achieved radar lock at 14 kilometers. 2 interceptor missiles were launched, accelerating past Mach 2. Their infrared seekers searched for heat signatures that barely existed. Both missiles lost lock and self-destructed. The system transitioned to guns. Twin 30mm cannons unleashed more than 4,000 rounds per minute, guided by a fire control computer optimized for fast, predictable targets. The drones did not behave predictably. Every 1 to 2 seconds, they executed sharp, irregular maneuvers, lateral shifts, sudden climbs, abrupt drops. The fire control algorithms failed to converge. Tracers passed meters from their targets. Nothing fell. The Panzer, designed to defeat jets, helicopters, and cruise missiles, was now confronting slow, cold, and erratic objects that exploited its mechanical and computational limits. Precision over volume. At 03:21 a.m., as the swarm passed into the system's dead zone, one drone broke formation and dove directly into the radar housing. Traveling just over 100 kilometers per hour, it detonated on impact, shredding the composite dome and collapsing the radar structure. Seconds later, a second drone struck the exposed core, detonating inside the system and destroying signal processors, cooling systems, and power distribution. A third drone impacted the command and control container, the coordination node for radar, air defense, and electronic warfare. In less than 20 seconds, the coastal defense sector lost its eyes and its brain. The launchers remained intact, operators survived, but the network, its ability to see, decide, and coordinate, ceased to exist.
Phase 2. Blindness becomes contagious. With the command node destroyed, surviving units reverted to local control. Voice radios filled with overlapping reports. No shared air picture existed. Each crew could see only what its own sensors allowed. Fighter aircraft were scrambled. Su-30SMs climbed to 6,000 meters, their radars theoretically capable of detecting targets beyond 100 kilometers. In practice, the drones flew too low and too slow, filtered out as ground clutter. Electronic warfare teams escalated to full-spectrum jamming, pushing output beyond 20 kilowatts per array. Civilian and friendly signals were drowned out. The drones remained unaffected. Their control signal did not come from the horizon. At approximately 4,200 meters altitude, far offshore, a relay platform rebroadcast commands vertically downward, outside the effective geometry of ground-based jammers optimized for horizontal threats. Interference passed beneath the control link without touching it. The defense did not simply lose capability, it lost coherence.
Kapustin Yar, strategic deterrence undercut. A parallel strike. Just hours later, on January 17, 2026, a second operation unfolded at the Kapustin Yar missile facility. Moments after two Orishnik missile systems completed a salvo toward Ukraine, 12 Ukrainian UAVs were already racing toward the site at 99 miles per hour. Each Orishnik launcher, with its support vehicles and radar, was valued at over $320 million. The attacking drones, 6 commercial DJI units, and 6 AN-196 attack UAVs cost less than a single pickup truck. A long-range PD-2 reconnaissance UAV orbited at nearly 10,000 feet, monitoring the site for hours without triggering high-alert responses. Russian crews, resting after the launch cycle, had regrouped vehicles and downgraded air defense posture. That pause proved decisive. Deception and delay. At 05:20 a.m., the first wave of 6 low-cost decoy UAVs approached from multiple directions. Their flight profiles mimicked routine training assets: no sudden acceleration, no mass surge, no unmistakable hostile signature. Radar operators hesitated. At Kapustin Yar, where missile tests are routine, engaging an unidentified contact carries serious consequences. For 2 to 3 minutes, no fire authorization was issued. By the time the deception was recognized, the main strike UAVs had already crossed into lethal range. 90 seconds that changed the balance. At 05:24 a.m., 6 AN-196 attack UAVs surged forward at 142 miles per hour. Each carried a penetrating warhead equivalent to 110 pounds of high explosive. Short-range air defenses reacted, but they engaged decoys flying autonomous profiles. The real attackers struck unhindered. 4 UAVs impacted directly into the launcher zones of the 2 Orishnik systems. 2 detonated nearby to ensure complete destruction of guidance modules, erection mechanisms, and support vehicles. Thermal readings recorded core temperatures exceeding 2,300 degrees Fahrenheit. Both launchers were destroyed beyond repair. Strategic consequences. The immediate financial loss exceeded $640 million, but the deeper impact was strategic. All Orishnik-related activities at Kapustin Yar were suspended. Training and testing halted for an estimated 6 weeks. Replacement assets must be redeployed from other regions. A temporary firepower gap now exposes Russia to follow-on strikes. Once again, cost asymmetry defined the outcome. Systems measured in tons and hundreds of millions of dollars were dismantled by devices weighing kilograms. The real lesson. By dawn, almost nothing appeared destroyed. Launchers stood,
Vehicles remained in place. The coastline looked calm. But the defense was gone. Every system worked as designed. Radars detected, missiles launched, guns fired, jammers transmitted. The failure lay elsewhere. They expected fast targets, strong heat signatures, predictable flight paths, control signals from the horizon. What arrived was slow, cold, irregular, controlled from above. Physics did the rest. Modern defense does not fail when it is weak. It fails when it is rigid. Power means nothing if it cannot adapt. Automation means nothing if it cannot question its own assumptions. The most dangerous moment in future conflicts may not be when weapons fail, but when certainty does. And when assumptions collapse faster than technology can respond, the question is no longer who has the most firepower, but who still understands the battlefield.
Enjoyed this deep dive? Tap subscribe and keep the latest defense tech coming straight to you. Thanks for watching. See you in the next video.